Why, hello, everyone. Hello, hello, and welcome to Embrace the Earth webinar 2020. I'd like to thank you all for joining us. I'm happy to see you folks here today with us to celebrate Earth Day. Who am I? Well, I'm Mick Posner. I'm your guest educator, host, and I'm also excited to lead you on our journey today, where you will meet 4 incredibly fabulous STEM professionals, and you will also learn about their careers and how we can all work together to embrace our planet that we live on. Again, my name is Mick Posner, and the reason I am involved in today's webinar, and it's probably better off if I just tell you my story. I grew up as an avid outdoorsman. I loved sports, just like many of you, I'm sure, want to get out right now. I grew up just the same. I started teaching American Sign Language classes, which led me to meeting more people. I met a hearing gentleman who was a rock climber. Most of you are familiar with mountains and rocks, right? Well, this gentleman climbed those mountains and rocks, which I found very fascinating. And at the same time, this rock climber was fascinated by sign language. So we agreed to a deal. He would teach me how to rock climb, and I would teach him how to sign. So in that process, I became an avid rock climber. I also traveled and climbed on various parks, various mountains throughout the country with him. Of course, I was teaching him sign language the entire time. And then I discovered that it doesn't end at rock climbing. Folks who are in rock climbing, well, the folks at that part of town were involved in environmental protection, cleaning of parks, rivers, trails, running, walking trails. They helped with cleanup and maintenance and preservation and clearing the trails so that they're easier to use. Plus, this particular rock climber was part of a group who met with local legislators. Now, if you're familiar, legislators are the ones who make the laws and rules for where you live. And so they have a lunch and met periodically. So I was invited, and I also met the legislators and thought it was really cool. What was fantastic is that the rock climbing group had a close partnership with these government officials. And at one time, there was a company who wanted to claim the water rights to that river. And the goal for that company was to extract water from the river to bottle it and sell it. However, that would have ruined life for any creatures or animals that were living in that river. And incidentally, it turns out that river had a beaver population with plenty of dams built in it. Now, if the water were taken to be bottled and sold, it would ruin their habitat. So this rock climbing group convinced the legislators to not grant any rights to that river to any businesses or companies, which was a big win. So I've now since then rock climbed all over the world. And a little while back, there's a popular company for outdoors wear, and it's called North Face. North Face sponsored me to go ahead and climb 2 mountain peaks in Colorado. I did both peaks in less than 2 days. These peaks were over 14,000 feet high, which means they're almost 3 miles up in the sky. So I successfully climbed both of those. I was sponsored by North Face, and now I work as a public educator in the public school system, K through 12. And I'm also involved in environmental preservation in my curriculum. And I also run a rock climbing club with hearing participants. So if they want to rock climb, they have to learn American Sign Language, which means that we're strengthening the bonds and partnerships within the community. And then we can use those bonds to reinforce our caring for our planet Earth. Again, I welcome you to our Embrace the Planet Earth Day 2020 webinar. And I also want to mention that we have a couple folks working behind the scenes. You do see that we've got our video and our PowerPoint coming up. On the PowerPoint, you can see a picture of those folks that are working really hard behind the scenes. One is Brian Milburn. The other is Jazzy Jones. We also have Megan Kluza and Keith Delk. These four folks are putting in quite a bit of work and have put in work already to prepare this webinar for you. Next slide, please. Before I introduce our panelists, our STEM scientists that are here with us, which I'm very excited to do. Right before we get there though, let me give you some information about the Zoom software. The slide here mentions accessibility. Zoom is best viewed on a laptop or computer. If you are using an iPhone, tablet, or even a mobile phone, it's not really recommended because you won't have a full view of the screen. Just be advised, our presenters will be sharing visuals, PowerPoints, and videos. You might not see those if you're on a smaller device. If you have a large tablet or a computer, you will be able to see those visuals as well. Also, we have sound on today's webinar. We have interpreters voicing what we're saying for those who would like to enjoy that. We also have the closed caption option available to you. If you'd like to click on that icon, you can go ahead and have captions live. Now, if you're experiencing any technical issues, go ahead and use our chat box to type that into the tech support team there. They will provide the support that you are asking for and get you moving along in today's webinar. So if you have any questions, any problems, again, be sure to use the chat box. Next slide, please. I would also like to add that if you look down towards the bottom of your Zoom software, next to the closed caption button, there's an icon that says Q&A. If during the presentation you have a question you'd like to ask the panelists, which we will be asking towards the end of the panelist presentation, you can type that in. We have our Learns team, will be monitoring that Q&A box, and they will share those questions with our panelists so they can respond to you. Also, I'd like to give you the heads up that the chat box will be turned off when we start with our first presenter. So if you have any tech issues, go ahead and ask now while the chat is on, because once our program begins, the chat is being turned off. You can also watch full screen, and if any of the sizing is off and you would like to adjust between myself and the PowerPoint, you should see two thin white lines in the middle of the screen. You can click and drag that, and that will resize the video or the panel. Again, any issues, please present them in the chat box. Now we've reached the moment we've been waiting for. I am so excited to introduce you to our role models. We are very fortunate to have four astonishing folks in their STEM fields. I will go ahead and introduce them, and I will ask them to tell us a little bit about themselves. First person I'd like to introduce is Dr. Alicia Wooten, and this is her sign language. Alicia?
Hi.
Alicia, hi. Would you mind sharing with us a little bit about yourself, who you are, what you do for work, and where you're from?
Sure. My name's Alicia. I am a professor at Gallaudet University. I teach biology, and for those of you who are wondering, my specialty is immunology.
Fantastic, Alicia. Thank you. Now I want to introduce Barbara Spiecker. Barbara, please come on.
Hello.
Hi, Barbara. Would you mind telling us just a little bit about yourself, where you work, who you are? Thank you.
Sure. My name is Barbara. I'm a PhD student at Oregon State University currently, and I'm studying marine science and ocean kelp and how it is that the atmosphere affects them.
Barbara, thank you so much for that. Now, the next speaker I'd like to introduce is Songhoa Choi. Hi. Song, would you mind telling us a little bit about yourself, who you are and what you do?
Sure. My name is Songhoa. I'm a biostatistician, and I specifically focus on deaf health and language deprivation.
Thank you so much, Songhoa. And then our fourth panelist that I'd like to introduce to everyone is Amie Sankoh. Amie?
Hello.
Hi.
Amie.
Go ahead, Amie. You mind telling us just a bit about yourself?
Sure. I'm a PhD student, and I am studying biology and biochemistry and cellular molecular biology.
Nice. Well, thank you. At this point, I'd like to move the slide forward. Right, tomorrow is officially Earth Day. Officially, it's April 22nd. So tomorrow will be the 50th anniversary. 50 years since the first Earth Day was celebrated in the 70s. 50 years is an incredibly long time. I'm curious if any of our panelists here have anything that they do in particular during Earth Day. Alicia?
Well, I was hoping to spend the day outside, but it's supposed to be raining tomorrow, so I'm not sure. But I am going to be participating with other deaf organizations. There's an organization that hosts exciting information for Earth Day, and I will be checking that out.
Thank you, Alicia. That's very neat. Now, before we move on to the next panelist, which is Barbara, right before I do that, let me mention one of our sponsors, and that is NTID, the National Technical Institute for the Deaf out of Rochester, New York. We want to acknowledge them and thank them for their support. Now, Barbara, back to you. What have you done for Earth Day?
I'm probably going to be spending the whole day working on my dissertation, but that's about weather, so that I feel like it fits. And Alicia and I are part of the Atomic Hands organization, and every week we've been doing something to gear up for Earth Day, and it's called Opt to Act. And so I look forward to our last part of that.
Well, thank you, and good luck with your dissertation.
Thanks.
Yes, Songhoa, Earth Day. What are you doing? Do you have any plans?
You know, I have a lot of seeds from last year's plants that I have yet to plant, and then tomorrow I'm going to take the opportunity to plant them and hopefully get bees to come into my garden.
Really neat. Fascinating. Thank you. Amie, can I ask what your plans are for Earth Day?
I'm doing the same thing as Songhoa. I love planting fruits and vegetables, and now is the perfect time since it's spring to plant those. So I'm going to be out gardening tomorrow. I love food.
Me too. I love eating, especially fresh foods and vegetables. I have two plans. One is tomorrow, my kids and I will start a new vegetable garden. So I'm really excited about that. It's been a long time in the making. So finally I've got time to do it this year. And another thing we're doing is right behind my house, there are trails that lead to a small lake nearby. And every year, my family, we get together and we go out and we go ahead and pick up any litter or trash that's just strewn about. That's what we'll be doing tomorrow. So I hope we have warm weather because just like Alicia mentioned, we might get some rain. So I'll have to see what happens tomorrow. But thank you so much, panel members, for sharing just a bit about yourselves, sharing your plans on what you plan on doing for Earth Day. We are so grateful for that. Let's move on to the next slide. Okay, so today's agenda, and an agenda is our plan for the day. You can see our plan on the slides. We have our role models that will be presenting. Alicia and Barbara will present together. So we have a total of 3 presentations today. Each presentation is incredibly interesting because you can be a part of it. And you will see today during the presentations that you can participate in your own Earth Day activities. Again, if you have any questions for our panelists or presenters, go ahead and type those into the Q&A box. Once we start with the first presentation, the chat box will be closed. Keep that in mind. You'll have to use the Q&A box. So let me ask, is everyone ready?
Yes.
Hey, okay, are you excited?
Mm-hmm.
One more thing before we get going. If you're not able to see the panelists, you need to resize your video windows. Use Zoom for that. There should be 2 thin white lines on the screen. Go ahead and click on that and slide that back and forth and you can adjust your video settings. Again, you'll want to select Gallery View. Make sure your Zoom software is set to Gallery View. And make sure that if you're experiencing any technical issues with Zoom, Make sure that you have the most updated version in order to avoid those issues. All right, I think we're set. Again, let me just extend my gratitude to NTID, and we'll go ahead and start with Songhoa.
Hi, I am a biostatistician, and
Hi.
today I'm going to be talking about data collected on global warming. We're going to be doing an activity, but first I'm going to explain what statistics are. Statistics is collection of data, potentially weight, height, size, color. Could be gender. That would be data. That is collected, analyzed, interpreted to explain what exactly it is that we're working on. So I'll explain this throughout our activity.
All right.
Before the activity, I've got a few vocabulary words that I wanted to go over. The first word is data. I just explained that. That's information, specifically numbers in regards to something. Mean means average.
Mm-hmm.
Yeah, for example, in the classroom, if you have all of the students, their weight added together, then the average of the students' weight would be the mean. The next thing, the low S smoothing, I'll explain about this as I get into the activity to help you understand it a little bit better. But it has to do with smoothing out a line to draw a more clear correlation for prediction. The next word is scatter plot. That is when you have a graph, for example, a pie graph, a bar graph. There's a lot of different kind of graphs out there. A scatter plot is a type of graph where the points are on the graph. You have it on the x-axis and the y-axis, and the points are graphed by their coordinates. Hopefully you understand that. Next. The NASA website, which is the National Astronaut Space Administration, mathematicians, physicians, engineers, scientists have all gotten together who are analyzing information from space. There's all sorts of information that gets researched and worked on. The great thing about NASA is they have so much information, and this information that I'm going to show is collected on the Earth from space. So astronauts have gone out into space, taken pictures of ocean, wind tendencies, any other weather things related to the Earth, and that information is shared to the Earth and collected as data. This started back in 1800, and the information is still continuing on every year. So we're going to have information today from 1800 to 2020 about the temperature of the Earth. 1801, it started the first year into it, and all of this information about the Earth and the temperature is collected to make a chart, and I am going to show you the chart, the table, on my next slide. I just want you guys to understand what it is that I'm talking about first.
Songhoa, I'm curious. So is that the temperature for both land and water?
It's the entire temperature, yeah. So that includes the ocean, the air, all of it, the 1 year mean.
Wow.
So it's intended to have the annual mean. And when I pull up the table, you'll see how statisticians' work looks.
Mm-hmm.
So from 1800 to 2020, there's been some significant changes. The temperature's gone up. It's gotten a lot hotter.
That's classic.
Why? Well, there's a story behind it. In the 1800s, factories were established. Cars were being made, later on airplanes. This caused a lot of CO2 production, which is carbon dioxide. Carbon dioxide is gas in the air. That's what pollutes our air, and that's what's raising the temperature of the globe. You might wonder why, but it's because there are a lot more cars in production and on the road.
A lot more planes in the air too, right?
Yes, absolutely.
It seems like carbon dioxide traps heat in the air. It locks it in.
It sure does, in our atmosphere. And yes, if you don't care about the earth, that would be driving a lot of cars, making a lot of things in factories. It produces CO2, which causes the temperature to raise. Next, you're going to see how it is that I made my graph. So next slide.
Okay, this is good information, Songhoa.
So this website, CodeApp, is really cool. It's a program that you can input statistics in, but it's very user-friendly and very intuitive. Even kids can use it. So children, teachers, you can all go to it and play around with it. So I'm not going to have you copy me right now. I'm going to explain this to you so then you understand it. And then when this webinar is finished, you'll have a chance to go and play with it on your own. So I'm going to explain the steps. All right.
Right. So you're saying you have a video, just show us later on those steps.
Yes. So CodeApp, in the right upper hand corner, you'll see that you can try it for free. Then this pop-up will come. You have two options. You can import the data yourself, or you can input the data yourself. If you already had a data set that you wanted to use, for example, I collected a file from NASA that has the global temperatures, and I'm going to be using that. So that actually will come with your file for you to use as well. So what you click here, and in the left, you'll see a drop down. You click on import. That means that you're bringing in the information from what's on your computer. Click there. Next, you see my file here that says temperatures. These are the different files that you have available on your computer to import and use. So my file is temperatures. I'm going to use that. I'm going to drag it down into the pop-up here. And then the tables will pop up. Very handy. You didn't hardly have to do anything.
About that.
You don't have to make the table yourself. The program does it. You just give it the data set and it creates the tables. Very easy.
On its own.
Yeah. So what do these tables mean? You see in the left-hand side, 1, 2, 3, 4, all the way down. The second column is the year, starting with 1800. The third column is the annual temperature mean. Remember I just explained about that? And the next column is the lowest smoothing, which I'll explain a little bit about in a little bit. So the year 1880, what was the temperature? Negative 0.96 Celsius. So Celsius is an international measurement system. That converts to be 0.75 Fahrenheit. Anyway, so I would like you all to vote. In the year 2019, what was the temperature in Celsius?
Should I ask a poll?
Well, I would like to know, what is the annual mean for the temperature in 2009? Was it 0.87, 0.98, 0.63, or 0.44? Go ahead and vote now.
All right, Song. So
Did we get our answers?
let's give folks a couple minutes to go ahead and read through the poll question and select their response. But I am wondering, because I never understood or never knew the Celsius But why it shows up in decimal format? Is there a reason why they do that with Celsius? Why it's in decimal format?
Well, with Celsius, it's because scientists throughout the world follow Celsius instead of Fahrenheit. Fahrenheit is an American system.
Really?
Yes. However, most scientists feel more comfortable with international units instead of an American metric system.
Right. I'm one of those Americans that uses Fahrenheit. So let's see if we got the responses to our poll question back. I think we have. Here we go.
Okay. The answer is actually the second answer, 0.98. So it's the second answer. I'm going to go back a slide and show you. See at the very last on the right-hand side, on the right-hand table, you'll see that 0.98C.
Wow.
Next. So if you want to make your own table, you see up in the left-hand corner, you click there, and you will get a blank graph that pops up. From there, you can start inputting the data from your table. At this point, there's nothing on the Y graph or the Y axis because that's going to show all of the information scatter out. You see that on the bottom graph? The information points are there on a scatter plot. So this is to zoom in on the scatter plot. So the information that you've taken from the table and put over into the graph will show up starting at 1880, yeah, negative 0.16. And then you can click in whatever data points you'd like, and they'll show up on the graph. Now you see the line is smoothed out here instead of having a lot of dots. This is something that statisticians use called the low S smoothing. What happens is it makes the line more smooth.
So that smoothing is showing the average, right? It's a total of the average. All the averages are being represented there.
It makes a model.
So statisticians rely on that, right? Instead of actually looking at the numbers, they can look at the model in the graph.
Yeah, it helps them calculate and make more accurate predictions. It's a complicated thing, but yes, this helps make it a little bit easier. Next slide. Now, you do have the option to change your colors.
Okay.
This second column, you can move information over. It will pop up at the bottom, and you see the different colors along the bottom. It goes from pink all the way to dark red. The lighter color, in theory, means something is weak, which in this application would be that it's cold. And the darker color means it's stronger, which would mean that it's hot. So you see from left to right the color change.
I do see that, but I also see it ramps up very steeply.
Yeah, it definitely does. Definite change. Now, if you want to change the color because you didn't like red tones, you can do that. Change the color, so that's on the left-hand side. You can play around with it. Like I said, if you don't like the red colors, you can change it to purple or black or whatever. You can play with that. The other thing is if you feel like the points are a little bit too small, you are able to make it a bit more bold. So this is what it is that I've been working on, the information from NASA. Now I will give you guys a chance to play with this at home. I will talk about.
Songhoa, before we talk about carbon dioxide, I got a question that was just asked, and I think it's a fantastic question to ask. The question says, with COVID-19, the coronavirus impacting the Earth, the planet, most of the world is staying home in response to COVID. So the question is, do you have a graph that shows the temperature before this pandemic? And does that graph show any curvature or any change in the slope?
It's definitely going to go down a bit. And part of the reason, well, maybe when we go back to work come fall or winter, whoever knows when that happens, when we start driving a lot more, it's going to go back up. I don't feel like it's going to drastically decrease at this point because it's such a short amount of time.
That's so interesting.
That's such a good question.
Right, with carbon dioxide, talk about that now.
Yes, CO2 means carbon dioxide. Carbon dioxide comes from factories, cars, airplanes, the gas that's being made. NASA collected information about the carbon dioxide amounts too. You see that graph? It just shoots straight up, right? Very much in line with the global temperature. So the cool thing about this graph is you'll be able to take it home and try it online for yourself. This is, like I shared with you about the file, I have a file about carbon dioxide, much like I had about the temperature, and the information gets put in a table and you get to try it on your own. So thank you for your time.
Okay.
Yeah, thank you for that. If it seems overwhelming, don't worry. After the webinar is over, this will get sent to you and there will be a video that explains it.
Mm-hmm. Fantastic. Well, thank you, Songhoa. That was amazing. I always learn something every time I watch your presentations. You're just absolutely astonishing. Now, before we move on, we've noticed some of the comments coming from the audience saying they can't see the panelists. Again, I want to emphasize that you should see two thin white lines in the middle of the screen, and you could slide those back and forth so that you can see the video monitors for the panelists. Songhoa, thank you again. This information is fabulous. I want to emphasize to everyone in the audience, you can try this data manipulation at home. At the end of our webinar today, we will have resources and links where you can find the data so that you can enter it and you can play around with graphing and changing of the colors and customizing the graph with the data points that you would like. So thank you so much again, Songhoa. Thank you. Let's move forward with the next slide, please. Okay. This is the fun interactive part where we use our polling to the audience. We've got the slide up. That's just for you to see. We'll have the poll question generate in a box. You should see that now. Now the question is, out of the four choices there, cars, lawnmowers, bicycles, airplanes, out of those four, which one produces or generates the most carbon dioxide? Go ahead and click and select whichever answer you think is the correct one. Now, while I wait and while you're reading that and clicking, I want to go ahead and share some fun facts about the Earth. Well, one fun fact that I like to share on Earth Day is the age of the planet. Is it a year old? Is it 100 years old? I doubt. Is it 100 million years old? Maybe not. The Earth is assumed to be between 4 to 5 billion years old, which is incredibly old. So imagine having Earth Day for 4 to 5 billion years. That is a long, long time. Okay, back to our poll question. Let's see the results. How interesting. It seems that we had a couple really strong answers. One contender was cars and the other is airplanes. Now, a lot of folks think that cars are generating the most carbon dioxide because they do have combustible engines that generate that exhaust. However, the fact is, it is airplanes that generate the most carbon dioxide because of the distance they have to travel. Now compare an airplane to a bicycle, which is human operated and has 0 emissions. We also have lawnmowers and cars, but airplanes takes the cake. A car typically has 1 engine and a single exhaust point. An airplane, for example, which flies back and forth over countries, a plane that is used in that type of travel has 4 engines typically, which means it's producing 4 times more exhaust. So the winner in this case are airplanes. Airplanes produce the most amount of carbon dioxide because they've got to circle the planet so much. Thank you for being a part of that question. Now we're moving on with our next presenters. Next slide here. I'd like to introduce Dr. Alicia Wooten, again, this is her sign, and Barbara Spiecker. Both will be presenting together, a really neat presentation, and their topic is ocean acidification, as we'll see soon. So, panelist, Barbara,
Absolutely.
you ready?
Yes.
Excited? Ready to go?
Yeah, let's go.
You're gonna save the planet now, right?
Of course.
Thank you. So we will go ahead and begin. Take it away.
Thanks. Alicia and I are going to be talking about how humans have affected the pH of the ocean, otherwise known as ocean acidification.
And oil spills.
Yes. So first we're going to focus on the ocean acidification, and here are the vocabulary words and the signs that go along with them. So ocean acidification is signed this: hydrogen, pH, acid, base, water, carbon dioxide, which is CO2, bicarbonate, HCO3, and carbonate, CO3. Ready to begin? Next slide. Why is it that we have Earth Day? And I would say everything in this world is connected together. You might think, oh, what I do doesn't have an effect on the world, doesn't have an effect on the Earth, but it does. The Earth has been changing because of what humans have been doing to it. Being that they're driving cars that produce a lot of carbon dioxide. Factories are being built that also produce a lot of carbon dioxide. That carbon dioxide is absorbed into the ocean. About 1/3 of all of the carbon dioxide in the atmosphere gets absorbed into the ocean, and it causes it to become more acidic. The pH, which is measured by seeing how acidic or how basic it is. If it's a high number, it means it's acidic. A neutral number, which is a 7, is neutral, and then a low number means basic. We have an experiment. It is going to show how the pH changes. This purple juice is cabbage juice. You know, you can make it at home by boiling cabbage and then blending it, or just blending it with water. So, if the cabbage water turns pink, that means it's acidic. If it stays purple, that means it's neutral. If it turns blue, that means it's basic. So we're going to add baking soda to it. What do you think is going to happen?
The baking soda is base, right? So I feel that once I add it, the liquid will change blue.
Let's see. You notice it's already changing.
Wow.
Baking soda is very basic.
Take a look.
Blue and purple. All right, Alicia, go ahead and add vinegar. Let's see what happens. Or what do you think is going to happen?
Well, vinegar is obviously an acid. I think it'll turn the solution pink.
All right, let's see. Wow, immediately turned it pink.
Here we go.
Very acidic. This is very much the same as our ocean. The ocean is absorbing carbon dioxide, and it is affecting the balance of the ocean. Next slide, please. You see the carbon dioxide molecules in the air being absorbed into the ocean, taking down to the bottom of the ocean. The carbon dioxide breaks apart into carbonate, and then bicarbonate, the bicarbonate and the hydrogen are there. They keep breaking apart, and then there's an excess of hydrogen. The pH is measuring how much hydrogen there is in the water. Before the 1900s, before the Industrial Revolution, the pH was 8.2 of the ocean. Now the ocean is becoming more and more polluted with carbon dioxide. The pH is being raised. So Alicia's got her drink, her straw. She's actually going to blow into the cabbage water, keep blowing into it for 5-10 minutes and see what happens.
Here we go.
So as she's blown more air into it, it becomes more and more pink.
Kind of in between these two.
Yeah, it becomes more acidic. Next slide. So carbon dioxide is increasing in the air. The ocean is absorbing it, and then it's breaking down the carbon dioxide and water and turning it into hydrogen. The pH used to be 8.1, and now it's 8.2. You might think 0.1 isn't a huge difference, but that's actually 30% more acidic than it was. That's a huge impact on marine life. For example, clams and crabs have a hard exoskeleton, and Alicia's going to set up an experiment here with an egg. The egg, the shell, is very similar to a crab or clam's exoskeleton. So we'll just call the egg is like a crab, and the liquid is like an ocean. One of them is water, and the other one is acidic. So let's see what happens. Now, fast forward, it's been 3 or 4 days. What do we think is going to have happened, Alicia?
Let me just reach here for a bit. I don't have my original egg, but here's this one. Here's the other.
Oh, the egg is looking very different. Oh, that's from the vinegar. It's all gushy and soft. It's not hard anymore. This same thing is happening with crabs and clams to their exoskeletons. Remember, the carbon dioxide is absorbed into the ocean, and then the carbon dioxide is separated out into hydrogen and to bicarbonate. The ocean is trying to maintain homeostasis, but throughout that, the hydrogen leaches onto the exoskeleton and starts to soften and weaken the exoskeleton of these crabs and clams. So what we do every day truly does have an impact on the ocean. Pollution, our cars that we drive, the factories that are producing things, everything is a symbiotic relationship. What we do in one place does have an effect in other places.
This is true because humans have affected and impacted the ocean. And at times, there have also been catastrophic oil spills. Oil spills have a tremendous impact on our environment. Now, the way the first Earth Day started, in case anyone isn't sure, about 50 years ago, off the shore of California, there was a huge oil tanker that spilled. And after that spill, people took action, protested, and established Earth Day. I'm going to review some slides at this point and introduce you to some vocabulary. First word, phospholipid. This is a sign for phospholipid. The second word, hydrophobic, which means something that repels water. And then there's hydrophilic, which is something that is attractive to water. And then we also have lipid, and this is a sign for lipid. And then we have the word immunology, and this is a sign for immunology. And then one more word, pandemic, and that's a sign for that. And last, we will end with virus, and this is the sign for virus.
Okay.
So we do know that oil spills happen, and they can happen throughout the planet. And when they do, they affect the land and the air and the environment around it. Now, how does an oil spill affect the ocean? I want to go ahead and talk about how oil floats over the water. Oil is a lot thinner than water, but that impact to marine life is tremendous. Birds, seagoing animals, sea otters, seals, all those creatures are impacted. And the way they're impacted is, for example, when a bird is flying and sees a fish under the water, despite there being oil on the surface, they will crash through the water, and at that moment, they will actually drink some oil because it goes into their lungs. And as they dive to eat a fish, the oil sticks to their feathers. So once they've gotten their fish, they can't fly out. That's one effect. Now, for creatures that live under the water, sometimes they float to the surface of the water, and at the same time, when they float to pop out of the water, they will swallow some oil, or the oil will coat their body, which means that their surviving abilities, because they're coated with oil, are affected. So there are more ill impacts than we even imagine. So what I want to do first is I want to show you exactly how water and oil, how they interact with each other. So I do have a cup of water, which Barbara has for me.
Yes.
Barbara, can I ask, if there was an oil spill, what would happen? Go ahead and spill some oil into your water. Do the folks in the audience think it'll mix? What do you think, Barb?
I think if I put the oil in there, it's going to fall to the bottom and then raise to the top and float there.
Well, give it a shot. Right. Folks, did you see that? When the oil was poured in, it did sink, but then it popped right up to the top. Next slide, please. This is the same concept as what we're seeing in the cup. We've got the water at the bottom and the oil floating right on top. Oil and water don't mix. Why not? Well, there's a couple things going on, and I'll cover them briefly. Now, the water molecule, H2O, are small molecules that can bind tightly together. So if you can imagine many water molecules bonded tightly together. On top of that, we have our oil molecules, which are a looser bond. So because water molecules are tight and oils are loose, they don't mix, which means that water is also denser. With oil being less dense than water, it floats on top of it because technically water is heavier. So if we zoom in, we can see that picture. We've got the oil sitting on top, and you can see we have the molecule on the screen. It's the phospholipid, which includes two parts. A phospholipid has a head, which again, because it's hydrophilic, is attracted to water, and the tail is hydrophobic, which repels water. So when the oil molecule falls into the water, the hydrophobic tail tries to avoid making any contact with the water. So it flips on its head. When that happens, it separates and the oil and water does not mix because again, they're repelling each other. So let's ask a question. If we go back to animal life, birds, otters, seals, all that marine life, if they're stuck or affected by an oil spill, how do we help them? Well, we use soap. That's how we help them. Barbara, what do you think is going to happen if you add oil to the water? If you add soap to the water?
Yeah, once I add the soap, I think that it's going to emulsify, mix everything all around together.
Well, let's see, try it. Pour some soap in and then shake it up.
Shake, shake, shake.
There we go, shake, shake, shake. My goodness, notice what happened. It seems the water and the oil have mixed slightly.
Yeah.
Now again, what exactly is going on here? Well, let's show you with our next slide. Look at the left image. That's a layer of oil. Again, we've got the oil molecules in yellow. And now the soap molecules are indicated in purple. Now again, those soaps are coming in through the lipids. You can see there's one lipid in purple. So when the soap bubbles up and is frothy, remember the hydrophobic molecule, portion of the molecule, will point away, and then the soap molecule is able to squeeze into that part. And they become small micelles, and then they surround the oil droplet, the oil molecule, which allows it to disperse. So once they start separating those oil molecules like that, it's a lot easier to wash off. And that's technically how we clean birds, bird feathers, when they're contaminated with oil, and so on and so on. Now, as a person who loves the environment, my passion, though, is immunology. So I'm sure folks at home are, of course, waiting for the coronavirus pandemic to ease, and then we can return outdoors. So I'd like to connect these two images. We have our example right next to the oil of a virus. You can assume it's a coronavirus. You see the yellow membrane. That yellow membrane consists of what? Of lipids as well, as we just mentioned. Again, soap tends to like lipids. Soap itself is a lipid. So when your parents, your teachers ask you to wash your hands and scrub, there's a reason for that. I'll give you the details now. When you go ahead and use soap on your hand, those soap lipids will enter the molecules. And then what they'll do is they'll start separating the molecules apart. So that yellow membrane holding the virus gets torn apart. And now, again, that virus can be dispersed. You can wash it away. The virus won't work anymore. That means you've dissolved the virus, which is really neat. So you see now why it's so important to remember acidification of the ocean, oil spills, and all the effects that we do are connected. You might sit back and think, oh, I don't have an impact on the planet, but you actually do. Everything you do affects our world. Even if you're sitting in the middle of a desert and are landlocked and no water around you, you can still affect our oceans. Whatever we do now travels across the planet and has impacts. Yes, we are all connected in that sense.
Thank you.
Thank you. Now this is Mick speaking. That was really great. I learned so much, but I do have a question, and I hope you can answer that before we move on to a poll that we're going to ask. Are there any possible solutions to cleaning up oil spills? And the reason why I ask that is because historically Earth Day was started because of a bad oil spill, right? Off the coast of California. But I'm curious, with our modern technology, with our enhanced technical and scientific knowledge, is there any good way developed now to clean up oil spills?
Well, with modern technology, it's still a challenge. So we've got some chemicals, they're called dispersants, that can, like Alicia had mentioned, turn it into small molecules and make it to be less likely that the animals will consume the oil. But we're still trying to come up with other low-cost solutions. We've thought about putting a machine in the water to suck up all of the oil. There's also other machines that dredge along because the oil's thick. I don't know. I hope we come up with a solution.
Right, and this is Alicia. I think it's important to understand that oil spills in the ocean are exactly the same as an oil spill in the big city. I'll try to explain that. There are hosts that live under the ocean and above the ocean. There's a lot of moving parts in the ocean. And so one impact continues to move along the ocean. So like, for example, coral reefs, we have to protect them. But yes, just like Barbara mentioned, there is more and more technology being developed to help gather that oil and remove it from the ocean, but we still have a long way to go.
I think the best solution is use electric and solar power instead of
right. And this is Mick. So now you're mentioning alternatives to oil for energy. So yeah, we are changing. Life is changing. We've got electric cars. Teslas. And so we're using more and more of that clean energy. So talking about solar energy that we get from the sun, what current challenges do we have? And why aren't we moving ahead full blown if we know the benefits of doing so? What are the challenges we're facing to making this shift?
Well, that's a challenge with sustainable technology. That's not my area of expertise. However, I know that it's fairly easily for small amounts, but for example, like Tesla, okay, it could be solar and you could drive around for a little bit, but what happens when it's really cloudy, or what happens on rainy days? So maybe you could drive 1,000 or 2,000 miles with questionable weather. We don't know what that would look like.
And this is Alicia. I think if you think about your home, about your house, a lot of folks struggle with the transition to solar panels, to be specific. A lot of people think it's not aesthetically pleasing, it's not a good fit to the house, it's also expensive. And that's another challenge that we face. How can we leverage or make the most out of the features we have communally, but still be able to apply those individually? Yeah, also, it's nice to have a face to folks who care about the earth. So when you mention aesthetically pleasing, people want things to look nice as well. Yeah. And you never know what those designs could change. But I'd like to thank you both now for your fantastic presentation. I enjoyed watching. I feel like I just learned so much. Thank you both. I want to go ahead and ask our poll question, which will check your knowledge about coral reefs. You can see the slide there. Now, coral reefs are a living organism. They are a living organism, which means that I'd like to ask the audience members where the world's largest coral reef is. Do you think it's Australia, Japan, Brazil, or even Bermuda? Go ahead, attendees. Select the response where you think the world's largest coral reef is at. Make your choice. While I wait, I'll go ahead and share another fun fact having to do with Earth and the environment. Now, the longest river on the planet is the Nile River. Do you know exactly how long that river is? Is it 40 miles long? 60 miles long? No, it's actually 4,160 miles long. Can you imagine swimming from end to end? Maybe even boating. Even on a boat, that would be a long trip. But the Nile River is the longest river on Earth. The reason I mention that is because north of the Nile River, where it starts, there's a basin. And the basin is critical for the community that lives near it. The basin provides fishing and nutrition, so it's critical to know that we protect our rivers and plants. Now, here we go. The results of the poll are in, and I can see, okay, good responses. It looks like almost everyone selected the correct answer, Australia. Unfortunately, the world's largest coral reef is not in Bermuda. Now, perhaps many in the audience are familiar with the Great Barrier Reef, which is that coral reef. However, the Great Barrier Reef is shrinking due to the rising temperatures of the ocean. So everything we learn in today's program is connected, as was just said, and you see that right. Now, before we move on to the next presenter or panelist, I want to move on and address some technical issues. We've been getting some comments in the chat box, so I figure why not go ahead and say this in American Sign Language. So if you're having trouble seeing the screen, now if you can see me, you should be able to see towards the top of the screen, there's a green portion at the very top. Right next to it, it says View Options in black and white letters. If you select that menu, there's a drop down, and at the very bottom, it says Side by Side mode. So you'll want to go ahead and click on that, and that'll open the PowerPoint to the side of the speaker or the presenter. So that's what side-by-side mode is. So you can see both items side by side. Again, you'll see two little gray or white lines in the middle of the screen. You can go ahead and click on those and drag it back and forth. And if you're on a touchpad of any sort, go ahead and tap it with your finger and slide it back and forth. And you can play around with that till you get the best view. I hope that helps. If you're out there and still having issues, please use the chat. And our CSD team is still working on getting those people's Zoom platforms set up. So we're still working with those people out there that are experiencing those issues. At this point, I'd like to move forward, and I'd like to bring on Amie Sankoh. Amie?
Hi.
How are you?
I'm good. How are you?
I'm good too. I just want to mention, Amie, I love your background. I like what you got going on back there. That's a lot better than mine.
I'm such a plant person, so yes, thank you.
I guess I should plant something so I could have some nice visuals too. Have you been learning a lot today?
So much. Yeah, so much great information I've been learning. A lot of new things.
Right? Amie, are you ready for your part?
Yeah.
Okay, well, I'll let you take over. You can have the video screen.
Thank you. So I've got two different experiments today. The first one really emphasizes regrowing seeds. So, and reusing items that you have from home. So I'm going to teach you how to grow some of your own fruits and vegetables and how to identify the seeds and roots to make your own. I'm going to show you a video on how to do this at home. So let's watch. Now that you've watched the video, I'm gonna wait for the next slide. So what do you think the plants have looked like after they've been growing for a little bit? That's a tomato. That's the onion. And that's the strawberry. You notice that the strawberry hasn't peeked out from the dirt yet. That's because all plants grow at different rates. It all depends on the seed and the coating. Sometimes they grow quick, sometimes they have a thick coating that's hard that makes it so that they grow slower. So we have to give strawberries a bit more time. And in another week or two, we'll start seeing some growth from the strawberries. You have to be patient, but you can grow some of your own food, regrow some of your own food. Next experiment is focusing on recycling. Because sometimes you can see that recycling doesn't seem like it works very well. Just because you can't see it doesn't mean that it doesn't happen. So we're going to do some experiments, and I would like you to use your observational skills to tell me what you think about if I mix two things together. So I have this yellow liquid, and I have a blue liquid. If I mix these two together, what do you think will happen? We're going to do a poll. Go ahead and pick what you think will happen. So I have my blue and I have my yellow. I'm going to mix them together. What will happen? It might stay the same. It might stay yellow, might stay blue. It might turn to a different color, maybe become green, might turn red, or maybe nothing happens. What do we think? Let's see the poll results. Oh, wow. The highest number was that it'll turn green. Let's see what happens. It definitely turned green. If you recycle appropriately, you can notice a big difference. Okay, now I've got 3 clear liquids. What do you think will happen? The 3 are mixed together, so when they mix together, what do we think? First, nothing will happen, it will be clear. It'll become white, it'll become black, become yellow, or become blue. What happens when I mix all 3 of these together? Okay, let's see what the poll results are. The highest percent said that nothing will happen, it will stay clear. All right, let's see. These color changes from light to dark to light to dark is called alternation. You can't see it, but it doesn't mean that it doesn't happen. The reaction still happens. So if you recycle appropriately, you will see the chemical reactions happen. I like to go over some vocabulary words. Chemical reaction, solution. You see the chemical makeup K plus 10 to the third, potassium iodate. The next is hydrogen peroxide, which is H2O2. And the last is starch. Those last three words I'm going to explain on the next slide. Next slide, please. Hydrogen peroxide is a cleaner. People use it oftentimes when they have a cut that they want to clean out to make sure that it doesn't get infected. Potassium iodate is used for a person who has been exposed to nuclear or radioactivity. The doctors give them the potassium iodate to help detoxify their body. Now, starch is in any carbohydrate. High starch foods would be rice, spaghetti, potatoes, bread. Now, when all of these are mixed together, a chemical reaction will happen. So the three mix together, the bonds break, the energy is released, and then a new chemical is made. The alternating reaction will continue for about 20 minutes. If you try this at home, you can find online. It's low cost, it's not toxic. So you can do this experiment on your own, and you can see why it's important to recycle. Meaning like recycling batteries instead of just throwing them in the trash, because you don't know what that battery is going to react with that could be causing damage to the earth. And we care about the earth. So any electronics, batteries, those kind of things, they can be recycled. Everything you can recycle to try to minimize the toxic impact on the earth. Thank you.
Well, Amie, that was extremely cool. I'm curious, that reaction you showed us, where is that found in the environment? Where does it naturally happen?
Well, starch is from food, and hydrogen peroxide, you can get that from like a drugstore because it's an antiseptic. You can use cuts to clean it. The potassium iodate, those are usually from a doctor, usually on prescription. However, you can get it on Amazon. You can order it on Amazon.
Cool.
Yeah. It's a low certified, low credential one so that kids can play with it. So if you're doing an experimentation, I highly recommend adult supervision.
That's a good idea. I'm also curious, Amie, and I meant to ask this before you started, about your educational focus. It seemed that you specialize in various different fields, right? You've got some plant science going on, some chemistry going on. Do you mind telling us a little bit more about yourself? Because I'm extremely curious. You are a person with many talents, and I'd like to know more about you. Tell us.
Well, first off, I am a chemist by training. I come from Africa. I was born and raised in Africa. Africa's very focused on cares about food and materials of the earth. So I kind of wanted to, but they focus a lot on living things. So I then got into biochemistry. First I started learning about chemistry, then it was biochemistry, and now I'm into plants. They've all correlated though. The path is the same, but then there's different routes.
So you're working on getting your PhD degree right now, right? What's your goal when you're done and you have your doctorate?
I'm going to become a professor. Yeah, that's my goal. I want to become a professor.
Nice. What are you going to teach specifically?
Science, specifically science, but then I'm a research scientist. So I want to be able to solve world problems
Mhm.
and be able to teach future generations about science because I feel like science can save us.
That's really neat. And I'm sorry to just start asking away. I've drawn in by your presentation, so I have lots of questions. You mentioned the plant science and how important it is in the field uh, of plants and growing. Now, how can we combine plant science and chemistry to lead to new medicines? Is that possible?
Yeah, absolutely. Every living thing, plant, organism has a reaction and has a response to other chemicals and has a response to a stimulus. So things being mixed together can lead to potential medication.
Nice, nice. Also, Amy, someone just asked a question in regards to safety. I'm curious if we have students out there that would like to perform that experiment, that color change reaction experiment, what do they do when they're done with the solution?
Remember, I talked about the potassium iodate. Make sure that you get a low concentration of it. That's what you would be able to get on Amazon, a low concentration. Because this has a low concentration, it's very safe. Once it's done, you can empty this out down the drain in a sink. That's fine with water, a lot of water, and that it is safe.
Running water. Yeah.
Right, it's non-toxic.
Oh, I did not know that. Okay, that's good to know. Thank you so much, Amy, for sharing that critical and important information. And thanks also for responding to me about your background. Of course, I got so drawn into you. It's nice to make all these connections with you folks in the STEM field. And thanks again. You're just sharing so much knowledge with us.
You're welcome.
And now we're going to go right back to a poll question for the audience. I'd like to check your knowledge, of course. We'll get that question up on the screen. You can see it now. So there's 4 different statements at the bottom of that screen. 3 of those statements are fact. 1 is not. So what that means is 3 are true statements, they're facts, and 1 is a false statement, it's not a fact. Your job is to figure out which one of those is false, not a fact. Is it tomato? First sentence says tomato is actually a fruit. The next one is mushrooms. Mushrooms have their own immune system. Is that true? And then one of the other statements says that a potato was grown in space via an experiment. Is that true? Were potatoes the first food grown in space? Another statement is corn is not part of the grass family. So when you look outside your house and you look in the backyard or front yard and you've got all the grass there, is corn part of that family? One of those statements is not true. Go ahead and select which one. So while you think about that, I'd like to ask another fun fact. No, we have the results already. I'll hold off on my fun fact till later in that case. Let me look through this. And actually, it seems we have a tie between the first food grown in space, which actually was a potato, and with corn not being part of the grass family. Okay, so corn actually is a part of the grass family, and they share a lot of similar DNA components. Tomatoes are a fruit, and there's a big misunderstanding when it comes to tomatoes because they do have seeds inside, which means they're a fruit. When it comes to mushrooms, amazingly enough, they do have their own immune system to protect them from disease or bacteria and viruses. So I'd like to move on now to the next slide, please. And now I want to go ahead and invite all the panelists to come back to the screen with me. I'd like to invite all you good folks back. We've had some questions come in. Okay, I see your windows open. Hi.
Hi.
So first, let me ask, are you ready?
Yes.
Okay, so before I start asking questions, let's again thank NTID again, because I can't emphasize enough how grateful we are for their support to today's webinar. Again, National Technical Institute for the Deaf in Rochester, New York. I'd like to encourage the audience members, if you have questions for any specific panel member, to use the Q&A box. You see it there towards the bottom of your screen. At the bottom, there's a menu. One of those icons says Q&A. Type in your question and I will facilitate those questions to the group. And again, thank you everyone for coming back. It's good to see you here on the screen with us. And remember, with the Q&A, we might not have time to respond to all the questions that are asked, which is fine, because we are going to look through those and make an additional video, which will be released. When we release this webinar, we'll have those additional comments and responses added to that release. So before we turn it over to the audience questions, I want to start first with the question for the entire panel, and I'll ask Alicia you first. I'd like to ask Alicia about a moment in your life when you realized, yes, I'm going to pursue a career in the STEM field. What was that moment for you? What changed in your life that made you decide to pursue STEM? I haven't had that moment. What I can tell you, Mick, is I've had many small moments that have been the catalyst for me deciding to stay in the field of STEM. I've always loved dinosaurs. I've always had an affinity for animals and creatures of all types, and that ties right into science. But when it came time for me to decide on what to do for my college years, I already knew it was going to be science-based, biology-based. I was thinking nurse at first, or medical field, and then that actually led me to where I'm at now. Fantastic. Barbara, let me ask you the same question.
You know, I'm very much like Alicia. I don't have a certain moment, but I never grew up wanting to be a scientist. I loved history. So I wanted to do something with that, but then once I got into college, I couldn't decide on a major. I picked science. I really struggled. The concepts were hard to understand. Having an interpreter with that was very difficult to understand. But I got to be involved with a grant with a mentor, which changed my entire trajectory into STEM. The mentor explained things one-on-one. I was able to understand things, and science became fun. So that, like I said, changed my trajectory of life, and here I am, ocean science.
Huh. Songhoa?
I grew up as an artist. I have always loved art, but in high school, I started getting into math. I like the visual representation of that, and math and art seem to go perfect together, especially in statistics. So here I am.
Nice. Now I'll ask the same question to Amie.
Well, I grew up in Africa, and I didn't have access to language in Africa. So I wasn't able to learn to communicate, but the only thing that I could learn and I could know was math. It was very visual, and I became very into math, but I kind of got bored with it and I wanted a challenge. And then I was exposed to chemistry in high school. It was an interesting challenge for me, and I thought, okay, there's something else. I still want to have math in there. So, what could I do? Well, I went to NTID and I met a fantastic professor who showed me some really cool demonstrations and experiments, and I decided science was it for me at that moment.
Amie, thank you for your response. I'd also like to remind our viewers and folks that are in the audience, you can go ahead and reach out to us. You can communicate with us by typing into the Q&A box.
Yeah, bring your questions.
We do want to hear from you. If you can't see all your panelists on the screen, please adjust the slider so that you can. We're going to go ahead and keep an eye on the chat and see if those questions come in, or the Q&A box, and see if those questions come in. I want to talk about an inspiration, right? For example, a lot of scientists back in the 70s and 80s some even in the 90s, who worked in the field, always point to what inspired them to become a scientist. And usually that tends to be Neil Armstrong's first landing on the moon. And that landing on the moon inspired a lot of scientists. There was no STEM field back then. It was just folks realizing that man had conquered the moon and all the technology that it took to achieve that. To place a man on the moon shifted many people's attention into the science and STEM fields. So I'd like to ask you, panel members, is there a person in particular? Is there an event in particular? Anything in particular that really inspired you to focus on the STEM field? And again, we'll start with Alicia. And this is Alicia speaking. I might steal a bit of Barbara's answer at this point, because a big inspiration for me is the group of deaf folks, scientists and technicians and everyone that's involved in the science field. If I wasn't exposed to other scientists, deaf scientists like I was at RIT, I wouldn't have imagined that it was possible for me. But because I had that initial exposure, I had the inspiration to continue and to ride that momentum. And now I see more and more deaf folks coming into this field. At Gallaudet, as I teach at Gallaudet, I see our future generation there. I see the generation of the future working hard on their research, working hard on their studies. Myself in particular, in immunology, I'm inviting more and more deaf folks to work along with me and learn with me so that I can continue that inspiration and that sense that I feel to maintain my momentum. Same question to you, Barbara.
Yeah, I gotta agree with Alicia. Throughout my journey as, there's not very many deaf STEM people. I want to continue to be an inspiration for others. It is enjoyable, it's fun, I enjoy the challenge. But I think also for me, working in environmental science and conservation, specifically with the weather, it's sad to see the changes that are happening in the world, and people, I want them to have more environmental knowledge. My family and friends, I try to educate them on things. Don't use single-use bags or plastic straws. I've tried to educate friends and family so that they can educate their friends and family, and we can preserve our planet as long as we can. We only have one Earth, and I'd like to make it a better place every day.
Really neat, Barbara. Now let's ask Songhoa.
I don't know about my inspiration necessarily. I am from South Korea and I grew up mainstreamed. I didn't see other deaf scientists. I saw my brother, who was really good at math and science, and he's a doctor now. And I remember thinking that I wanted to be like him, but I was always told that I couldn't because I'm deaf. No, you're not going to be able to do that because you're deaf. Horribly depressing. Deaf students weren't able to do that kind of thing. But then I went to Gallaudet and I saw so many doctors and scientists and thought, well, I see, oh, these deaf people can do it, then I can do it too. So I met a math professor, a statistician, who really inspired me, and I thought, oh, I want to do that. I want to do that same thing. So now I'm a statistician.
Fascinating. Let's also ask Amie.
Well, I agree with the three of these ladies. I didn't necessarily have inspiration growing up, but when I got into college, it was a game changer for me. I saw other students, I saw the deaf community, and more scientists. I was exposed to them. You know, Alicia and Barbara, you said you hadn't really been exposed to that until you went to deaf schools. Yeah, you see those deaf scientists and think, I can do that too. It gives you the motivation and inspiration. And I have that inspiration every day. Sometimes it's really challenging, but I love the positive outcome and feeling like I can help future generations and grow more deaf scientists, hopefully.
Amie, I agree with you. That's correct. We need more deaf and hard of hearing scientists. We need to grow the pool. And we have a list of growing questions for the panel. I want to go ahead and share some of those questions from the audience. One of those questions is, what what's one of the biggest challenges you're facing in your career now? And what are the challenges you face in working with hearing people? Alicia, would you like to respond to that? And this is Alicia speaking. Okay, what's the most challenging thing for me currently? Okay, coronavirus aside, trying to figure out what my next research project or plan would be. I just graduated with my PhD just last year, and my focus right now is pneumonia. So I am transitioning to Gallaudet, and at the moment, I'm trying to figure out how to continue my immunological research. So that's one challenge that I'm focusing on and dealing with this summer. I've got to get that figured out. And I also have to figure out and plan what my students will do with me. Now, as far as working with hearing people in the hearing environment and those challenges, that's a particularly tough question that I don't think I could respond easily to, because there is a lot of give and pull, right? There's a lot of us as deaf folks giving of ourselves and making that accommodation, but where's the reciprocal? I see, says Mike. Okay. And this is the interpreter speaking. The screen is frozen.
Yes. Alicia's screen is frozen.
Mike is saying, I think the screen froze for just a bit. We're going to get tech support on this. So Alicia, hang in there. Barbara, do you mind hopping in?
Sure, yeah. A big challenge in my field is, the field in general, I guess, is connection to people. In everyday life, we're also consumed with our lives and our families and our own school, that we forget that we're a part of a whole, and that should affect how we do things every day. We need to make sure that we communicate with people, help get other people interested and caring about the work that we do. The next question, the challenge in my field with working with hearing people, as Alicia mentioned, the list is extensive. I don't know if I could answer any of it specifically in a short amount of time, but I have to learn in my field, and I have to learn how to collaborate with hearing teachers, and they have to learn how to work with a deaf person and how to work with an interpreter who isn't an expert in our field and our vocabulary. I'm still doing research, and there's a lot of hats that I wear as a researcher, but it's making it so that there are a lot more teachable moments, but it's a challenge.
Thank you for that, Barbara. Songhoa, same question.
Yeah, a big challenge in my field is there aren't very many statisticians like myself. So it's very hard to collaborate or have a discussion with somebody about that. So that's a challenge. It's a lot more study on your own kind of things. Statistics are constantly changing, approaches are constantly changing, and I have to kind of navigate through those waters by myself for a lot of it. The challenge working with hearing people, it's the same challenge as working with interpreters a lot of times. When interpreters don't have math backgrounds or statistics backgrounds, it makes it so that there's a lot of misunderstandings and miscommunications because they're not common vernacular that an interpreter would necessarily know. And there's not enough of that education out there.
Okay. Amie.
Well, they're kind of both together for me. A big challenge is communication and having to work twice or 4 times harder than my hearing counterparts. Because I never went to grad school, I didn't learn some of these things. Sorry. When others haven't gone to grad school, they haven't learned some of this patience, and it takes a lot of patience. It takes a lot of energy, and I'm hoping, as I said before, that I can make a difference for the next generation of deaf people who come to the university, because my life has improved leaps and bounds from what it was before. I remember before I would go to a meeting and they wouldn't request an interpreter. I'm like, wait, I have to request an interpreter. I didn't even know about this meeting. People in my environment thought that I was always the one who had to request an interpreter, even though I'm the one in the training environment or the class. So working with hearing people, it can be great if they're willing to be accommodating, they're willing to pay attention, they are flexible and helpful. You just have to make sure you keep communication lines open. It does take a lot of energy and work, though.
Neat. Thank you so much, Amie. However, I do want to give Alicia an opportunity to finish her response. I see she's back. No worries, Alicia, about that. You had started telling us that you don't really have one single answer for us. Yes, and then my power went off, says Alicia. There's a storm coming in, which is why the power went off. Thank you, says Mick. This is Alicia again. We give a lot. As deaf people, we fit in. But when do the hearing folks reciprocate? If we could both give at the same time and come together, then things would work and the struggles would be minimized. There is a limited knowledge and a limited awareness with hearing folks as to how to include us, because they don't realize that they should put in the effort to learn sign language. They should put in the effort to learn other modes of communication other than asking, do you read lips? So the big question here is, and the challenge is, how do we reduce the burden on our shoulders, and how do we shift that to hearing people as well? And this is Mick. Thank you, panelists, for responding to that, but we do have more questions coming in from our audience members, specifically for Amie. The person says, in your presentation, you, quote, said, science can save us all. A nice quote there. So the person asks, what is your next project, Amie? And what current projects should the world focus on now to save itself?
My current project is focused on plants, but the next project for the world to save itself, well, I feel like plants can be the solution. Plants help us understand communication is so important, right? Deaf people, we know communication is integral, but you can get so much information from plants. They have intracellular communication. They communicate with each other. If we can understand how it is that they communicate with each other, we can stop things like pandemics or viruses spreading, because we can understand that intracellular communication, the communication from cell to cell. It's incredibly complicated. My part is just a small part of it, but I feel like it's all part of the greater whole. And that's why we have so many different scientists, Alicia, Barbara, Songhoa. We all work together to save the world. I cannot do it on my own. It's gonna take a lot of different scientists in a lot of different fields to do their part, but I feel like we can save the world. My next project, I don't know. I'm just focused on my current project right now, and that's trying to understand intercellular communication with plants.
Amie, neat. Thank you for defining that for us and telling us about that. And you're right, no single person can carry that weight and solve all our issues. It's a group effort. We all need to come together so that we can make that positive impact on our planet. I also would like to ask, see if there's anyone here, any graduates from RIT and TID? Anyone here? See by show of hands? Okay. Me too, myself included. Just like those of you. Songhoa, you're RIT.
Gallaudet.
You're the only one? Okay, that's neat. That's awesome.
Grad school, yeah.
And you work at the University of Rochester, right? Nearby RIT.
I'm so nearby.
Okay, we will accept that. But yes, myself, I'm a graduate of RIT. I have a BA and a master's from there. I have great memories as well. Something else I'd like to put out, and I know that this might be a bit a surprising question, and I want the audience to get to know you a bit better, is the point of this. So we've got a two-part question. We're looking for short answers here. First question, give us one word that comes to mind when you think of our planet. One word right away, okay? That'll be the first question. Second question is, part of taking care and preserving of the environment is also taking care of animals. So the question is, what is your spirit animal? Again, audience members would like to know the answers to these two questions, so I'll give you just a couple more seconds to think about it. When you think of our planet, planet Earth, what word comes to mind? Second part, what is your spirit animal? So we'll start with Songhoa. Since you were just last, let's go, Songhoa.
When I think of our Earth, I think green. Trees, grass, everything. The first word is green. My spirit animal? I love cats. I like dogs too, but I'm like, my spirit, I feel like much more aligned with cat.
Neat. Okay, Barbara.
First answer, I would say, when I think of Earth, I think connection. That's the first word that comes to mind for me. My spirit animal, I love ocean animals. So, catfish?
Parrotfish?
Yes, a parrotfish, thank you. They actually eat coral, and you know what they poop? Their poop becomes sand. So they clean the coral and then add more sand. I think that is so cool.
That is really cool, Barbara. And now I'll ask Alicia. This is Alicia speaking. Okay, my one word is growing. I feel like things constantly change. I feel like we are all always growing. Animal life, human life, and the planet itself is always in a state of growing. So my spirit animal, I would probably have to say a panda. Now, I have seen videos of pandas, and I really like the way they roll around and are so comfortable just rolling around on the ground. I tend to fall a lot, and I'm always back and forth, so I'm kind of like a panda. And this is Mick. Well, thank you. Alicia and Barbara, I just had a thought. As you leave, you mentioned atomic hands. Someone mentioned you have bloopers with the power going out, because Alicia, your power just went out. Somebody says your atomic hands program had the power going out as well?
Yeah, Gallaudet.
Okay. Amie, what is your response to those two questions?
The first word that comes to mind is sick. The earth is sick. We need to change that. I think that's the word that comes to mind right now. We need to reduce our illness and become healthy. My spirit animal, I always call myself a lion. I'm very quiet, but when the time comes to advocate, I am loud. I advocate a lot and I roar. So I really advocate for changes and improving the world.
Nice, Amie, nice. Thank you for that response. At this point, I do have one more question. I'm really curious if any of you present to middle schoolers. And if so, when either of you, again, the panel members here, look back to your middle school years, was there anyone that made a difference in your career path? Alicia, we'll start with you. Gotta look back. This is Alicia. Yeah, middle school was a long time ago. And this is Mick again. Just anyone that might have impacted you and made a difference during your middle school years. This is Alicia. Well, I didn't have the best experience in middle school. I was mainstreamed. I was the only deaf person there. I didn't know sign language. I didn't have an interpreter. I had a limited group of friends. I had a limited amount of access. So I think what I learned from my middle school experience is very critical, is that you've got to rely on other people. You have to find people. Now, life is always changing. It's never static. And like I said, my word is growing. If I had stayed where I was in middle school, I would have never grown. So I think I've grown to a much better place now. Okay, thank you, Barbara.
Well, I went to a school for the deaf, and in middle school, I remember in science class, everybody signed. So there was a lot of collaboration on group projects and hands-on, very visual. And that stuck with me. And I feel like it carried on into my life and my relationship with people. And atomic hands and making sure that things are hands-on to make it more memorable for people.
Songhoa.
I don't really remember too much of middle school. Kind of like Alicia was saying, I was mainstreamed. I was the only deaf kid in my school. And I'm thinking, okay, I would study every day. I studied all day. And when I would come home, I didn't really have many friends. I remember math class, going to math class, solving problems. I really enjoyed that. I didn't understand the teacher. That was common, but I could solve the math problems.
Thank you. Amie, you're next.
Middle school, I had no language at that point. I had nothing. I went to a hearing school, not even, you wouldn't even call it mainstream. I just was with a hearing school, no interpreter, nothing. I was 12-ish that time in middle school, and that's when I moved to America, and I didn't have any language. The doctors were trying to figure out how to work with me. And finally, at 15 in high school is when I started learning sign. So middle school was really nothing for me. It was truly just about survival, not actual communication, but surviving. And once I was 15 is when I finally was learning sign language, and I just thrived. I took off once I was able to have a language, but middle school for me, nothing.
Amazing.
Yeah, having access to language, it makes such a difference in life, right? I'm jealous of Barbara.
Okay. Folks in the audience, please stay. Panelists, please stay. I really appreciate the panel members' responses, in-depth responses to those questions. The folks here look forward to learning from your experiences. They appreciate you being here so that we can increase deaf professionals in the STEM field. Again, thank you again for your candid, outright responses to these questions. If we can move the slide forward, please. So we've all watched the presentation, which has been a combination of resources that are available online. Those resources are listed here on the slide. As you can see, there's CODAP, which is a website. There's also Earth Day official website. You can click on those for more history on Earth Day and a bountiful amount of activities. Again, there's pages and links, so you can see if there's any local activities happening near a region or an area near you. So you can use the earthday.org website for that. And then there's also the Animals and Marine Life, the Biological Diversity website. And if any folks here are curious about getting out and visiting national parks, of course, with coronavirus, we aren't able to go out, but the National Parks Foundation has provided a virtual tour so that you can visit any park within the nation. You can navigate those parks from the comfort of your home. I've been spending a lot of hours myself visiting those parks, so I've been to many parks virtually as well as physically. So if you have free time later and you've seen the national parks virtually, you can always visit them in person as well. So I just wanted to touch upon that slide with the resources that are offered there. And we have a couple more resources in the next slide. Now these resources are for teachers, educators, and parents. You can visit csdlearns.com and you can get a copy of Embrace the Earth Toolkit. You download that, and there's 5 days worth of activities in those toolkits, specifically developed for middle school age students. There are videos in American Sign Language. The videos are captioned. They are fully accessible. And so you can go ahead and turn to those resources when you'd like. Also, we'd like to point out that this week we'll be celebrating Earth Day. Tomorrow is the official Earth Day, but this entire week you can spend time online looking into Earth Day. Another great website is weather.com. You might be asking why? Why is weather.com a great website? Because the weather is part of the planet and part of the environment. And at weather.com, they have more activities that you can participate in, download, and do. And there's plenty of worldwide global information at weather.com. So keep your eyes focused on Earth Day information. And also, we've got a little at NASA there. NASA has over 500 social media accounts. So no matter what platform you use, you're guaranteed to probably have a NASA channel on several of those because there are NASA accounts throughout. So in order to find those, use at NASA on your favorite social media platform, whether that be YouTube, Instagram, even Snapchat, TikTok. NASA has channels there, so you'll want to search for at NASA to find their account. The reason I say this is because NASA is releasing a large amount of data, information, and pictures in regards to Earth Day. So you'll want to keep an eye out for hashtag Earth Day at home for any creative ideas on how you can participate in honoring our planet via Earth Day from home on your favorite social media platform. And again, we'll move on to the next slide. So it's time to wrap things up for today. And we hope that we've inspired you to embrace the earth. CSD Learns will also be sending a survey. So please take a few minutes to respond to our survey questions. You do have a chance to win a gift card. We will announce that winner after the surveys are responded to. And also you can follow NASA on social media, and you can also follow CSD Neighborhood on Facebook, Twitter, and Instagram as well. And it's at CSD LEARN, interpreter error, CSD Neighborhood. Go ahead and keep up with us for any new projects or webinars that might be released. That's the best way to get our information, at CSD Neighborhood. Next slide, please. Of course, there are many folks we'd like to thank today. Today's webinar would not have happened without our amazing panelists and presenters. Let's take the time to thank each one of the 4 folks that joined us here today for their in-depth, rich, and very, very edifying presentations. This took me back years, like when I was young, and learned so much. I hope the people out in the audience also took in some knowledge and have takeaways and have benefited from being here with us. We appreciate your attention and the efforts you have put into today. This team made a fantastic team today, so I'd like to thank the panelists. Also, I'd like to thank CSD and CSD Learns for working behind the scenes. There are a lot of moving parts. There's a lot of communication that has to be arranged and a lot of logistics to work through. I want to give a shout out to the fantastic CSD Learns tech support team that's been working to keep everyone entertained and enjoying the webinar today. We'd also like to thank RIT NTID for their support in today's webinar. They believe in the mission of Earth Day as well. So again, thanks to RIT NTID, and if you would like more information on that school, please visit their site online. And if we can move the slide forward. Yes. So we've reached the end of our webinar. I want to thank the audience for joining us and being here with us today and spending that time together. We'd also like to thank our 2 interpreters that have been working behind the scenes really hard to keep up with our presentation. We'd like to thank them both. And also, last word and reminder to everyone in attendance. And before I do that, we'd also like to thank our captionists. We have a captioner who is working hard on transcribing everything we're being said here today. Now I'm at the point where I can say my last word. We have one Earth, one planet. If we, amongst the different fields, work together, STEM fields, creative fields, all the various fields, if we can join hands and collaborate, we can make this planet a better place to live. We are all surviving through the coronavirus pandemic. We've seen how bad things can get, and we know how good things can become as well. So as we anticipate any future changes in our daily lives to our environment, we can keep that in mind. So remember, we've got to take care of our planet. Audience, thank you for your questions. Feel free to reach out to CSD if you have any more questions or would like to learn more information. As we mentioned, we will have some of the questions that were asked and weren't responded to added to the recording of this webinar. I'd like to wish everyone a great day. Have a fantastic Earth Day 2020. Thank you again, and goodbye.